All right, we are going to continue talking about real zeros of polynomial functions. And we already talked about the upper and lower bound test for real zeros. Again, remember, if your zero is greater than, or if the number you're checking is greater than or equal to 0, in other words, it's positive, and every number in the last line is non-negative, meaning positive or 0, then it's an upper bound. If k is negative and the numbers in the last line alternate between negative and positive, then that number is a lower bound. Okay, so they're going to give you an interval. They're going to say, prove that all of the zeros to this function fall within, let's say, an interval from -3 to 7. Well, what you do is you test the upper and the lower, test the upper interval, the 7, to see if it's an upper bound. Test the lower interval to see if it's a lower bound. If both are yes, then you've proven that all zeros must lie in that interval. If 1 or 2 are no, then you've proven that there are zeros outside of that given interval. Okay, so it says prove that all of the real zeros of this function must lie in the interval between -2 and 5. So they're looking at this graph. There's -2 and there's 5. And what they want to know is, do they see all of the zeros they can see? Well, I know they can, because at most there can be, for a 4th degree, there could be 4 intersections or 2 or none. This one has 1, 2, 3. I can see all 4 of them, so I know it's not, but we're going to prove that it's not. So if I do if I test -2 to be the lower bound, I put -2 in the hole. My coefficients: 4th degree coefficient, 3rd degree coefficient, 2nd degree coefficient, 1st degree coefficient, and constant. Okay, draw the line, and 2 comes out, goes to the store, multiplies, brings back -4, -7 eats -4, comes out -11, times -2 is +22, -8 eats +22 and comes out 14. 14 times -2 is -28. +14 eats -28, comes out -14. Times the -2 is a +28, which comes out +36. And if I look at the signs, positive, negative, positive, negative, positive. So they alternate, which proves that -2 is a lower bound. So I know that nothing else is there's not going to be any more x-intercepts over here. So now let's test our upper bound. Put 5 in the hole. 2, -7, -8, +14, and +8. 2 comes out, multiplies by 5, brings back 10. -7 eats 10, comes out 3. 3 times 5 is 15. -8 eats 15, comes out +7. 7 times 5 is 35. 14 eats 35, comes out 49. 49 times 5 is 9 times 5 is 45, 22, 45, plus 8 would be 253. And if I check the signs, positive, 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 positive. So since the bottom line is all positive, 5 is an upper bound, which proves that all the zeros that are possible fall within that interval, and I can see that it does on the graph. All 4 fall between. Alright, this one says find all of the real zeros. Well, there could be 4. There are 4. I can tell by the graph. There are 4 zeros. Okay, my goal is, I'm not sure where that one's at. I'm not sure where that one's at. I'm not sure where that one's at, but I am sure that this one is at 4. So if I use a combination of my graph and my PQ list, okay, remember your P's are going to come from 8, your Q's are going to come from 2. So factors of 8 are 1, 2, 4, and 8. My Q, I need factors of 2, which are just 1 and 2. So my PQ list is 1 over 1, 1 over 2, 2 over 1, 2 over 2, 4 over 1, 4 over 2, 8 over 1, 8 over 2. So that's plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 1, but I already have it, plus or minus 4, plus or minus 2, I already have it, plus or minus 8, and this would be plus or minus 4, and I already have it. So there's the 4. I can see that it crosses at positive 4. It does not cross at negative 4. It does not cross at positive 8 or negative 8. It does not cross at positive 1 or negative 1. It does not cross at positive 2 or negative 2. Could this one, so I'm looking at positive 1/2, well, it's not there. This might be negative 1/2. So the two that I'm sure of, pretty sure of, is from the list is negative 1/2 and positive 4. So if I can divide by those, that will get it down to a second degree function, which then I can use my quadratic techniques on to find the remaining zeros, which are clearly going to be irrational. So let's do the negative 1/2, because I know you guys hate fractions. My fourth degree coefficient, third degree coefficient, second degree coefficient, first degree coefficient, and my constant. Alright, 2 is going to come out. Negative 1/2, in other words, negative half of 2 would be negative 1. Negative 7 eats negative 1, comes out negative 8. Half, a negative divided by a negative is going to be a positive, and half of 8 is 4. Negative 8 eats positive 4, comes out negative 4. A negative divided by a negative, or times a negative, I should say, is a positive, and half of 4 is 2. 14 plus 2 is 16. Negative times a positive is a negative. Half of 16 is negative 8, which gives me a remainder of 0, which it should, or my graph is wrong. Okay, so now we've depressed that down to from a fourth degree to a third degree. X cubed, x squared, x, and a constant. Alright, so now I'm going to take my other sure one and put it in the hole, and I'm going to use my depressed polynomial coefficients, third degree, second degree, first degree, constant, and I'm going to depress this down to a second degree. So 2 would come out, times 4 is 8, negative 8 eats positive 8 is 0, 0 times 4 is 0, negative 4 eats 0, comes out negative 4, times 4 is negative 16, which again gives me a remainder of 0, and it better, or my graph is lying to me. So now we've depressed this down to a second degree, x squared plus 0x minus 4, which can be written as 2x squared minus 4. Now I've gotten it down to a second degree. So to solve a second degree, I can set it to 0 and use a quadratic technique. Since there's no first degree x, I can use the square root property, which says isolate what's being squared and kill it. Take the square root. So I'm going to add 4. That gives me 2x squared equals 4. Divide by 2. And I get x squared equals 2. Take the square root of both sides, and I get x equals plus or minus the square root of 2. Which is 1.4 something something something, which is about right there, and negative 1.4 something something something, which would be about right there. There's your positive square root of 2, there's your negative square root of 2, there's your 1/2, and there's your 4. Okay, so all of my zeros would be a negative 1/2, a positive 4, a positive square root of 2, and a negative square root of 2. Okay? If they then wanted me to write the polynomial in factored form, I could say my function would be x plus 1/2 times x minus 4 times x minus the square root of 2 times x plus the square root of 2. Okay? Alright, so you try this one. Hit pause, come back when you're ready. Sorry, my pen has to catch up. Come on. Alright, well if we make our PQ list, P is, there it goes. P is going to come from our 90s, from 90. Hold on just a second. Alright, P is going to come from 90. All factors of 90 would be 1, 2, 3, does 4 go into 90? Twice, no, 5 goes in 18 times. The 6 go into 90. Yeah. 6 goes into 9 once. Take away, that's 5, 6 and 15. 7, no, 8, no, 9 and 10. That's it. My Q is factors of 1, which are just 1. So my PQ list is basically all of these, plus or minus 1, 2, 3, 5, 18, 6, 15, 9, 10. So if I get a picture on my graph, and I look for the ones that I can for sure see, this one looks like -3. This one looks like, I don't know what that is, that's between, I don't know what that one is. But this one, 1, 2, 3, 4, looks like it crosses at 5. So I'm going to divide by -3, put -3 in the whole, 4th degree, 3rd degree, 2nd degree, 1st degree, constant. Draw a line, bring 1 out, times -3 brings back, -2 eats -3 is -5. -5 times -3 is positive 15, -21 eats 15, and comes out -6, times -3 is positive 18, which comes out as a positive 30. 30 times -3 is -90, which gives me a remainder of 0, which depresses my polynomial down from a 4th degree to a 3rd degree. So now, if I divide by my other one that I'm sure of, which is positive 5, I'm going to put positive 5 in the whole and use my depressed coefficients, which would be 1, -5, -6, and 30. Okay, draw my line, and 1 heads out, times 5 is 5, -5 plus 5 is 0, times 5 is 0, -6 eats 0, comes out -6, times 5 is -30, -30 eats positive 30 with a remainder of 0. We've now dropped this down to a 2nd degree, so that's x squared plus 0x minus 6, which turns into x squared minus 6. Okay, that's my quadratic factor, which I can solve using quadratic techniques. So set it to 0 and solve. Again, you can use factoring, completing the square, anything you want, but when there's no 1st degree x, the fastest way is square root property, which says isolate and kill it. So I need to isolate x squared, so to get rid of plus minus 6, I'm going to add 6. That gives me x squared equals 6, square root, and I get x equals, I can't break it down, I can't simplify it, so plus or minus the square root of 6. So we have -3, which is rational. We have 5, which is rational. We have a positive square root of 6, which is irrational, because if you type it in the calculator, you get a decimal. And if you try and enter it, you won't get a decimal back, which means it's irrational. And negative square root of 6, which is irrational. Okay? Alright, so how do you determine the upper and lower bounds of a real zero? We talked about that yesterday, and we talked about that one yesterday. Alright, to determine when supply equals demand. Anytime you're trying to figure out when one function will be equivalent to another function, you're talking about systems of equations. And to solve them, you want to find their intersection point. So we're going to do this with the graphing calculator. You type your supply equation into y1, your demand equation into y2, and then you calculate the intersection point. And that's where the price or the supply will equal the demand. Okay? Alright, so it says the Cool Company determines that the supply function for its basic air conditioning unit is S of P. They're using S of P for the supply function. And its demand function is the D of P function, where P is the price of the air conditioning unit. And they want you to determine the price for which the supply equals the demand. So the first thing we're going to do is go to the calculator and we type in your supply equation for y1, your demand equation for y2. Okay, then you're going to set your window. I had no idea what really to set it to, but I saw this 150, so I thought, well, I've got to go at least that high. And again, I went from knowing, again, if you think logically, supply and demand, you're talking about lots of money, so your window needs to be pretty big. And I got this graph. And I'll be honest, I messed around with the window a little bit so that I could get a clear view of the picture. Okay, this is a cubic function. That's your S shape. That's the first one. Okay, the second one is a second degree, which is your parabola, which is this one. Okay, and their intersection point is right there. So if I calculate the intersection, I get an x coordinate of 21.858 blah 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 612. Let's round it to that 8 will bump that 5 up to a 6. And y is 92.66. Okay, so what does this mean? Well, x was the price, yes? P of p, that's where your x is. So if the price is $21.86, okay, then the supply will equal the demand. Yeah? Alright, so you try this one. Come back when you're ready. And hopefully you got, $96.24. If you didn't, I'm trying to get there. Okay. So again, you should have typed this in for y1 and this in for y2. And I set my window from -10 to 130, counting by tens. My y's I sent from -10 to 3,000, and I counted by 200s. And I had to play around a bit, but I finally liked this picture where I could really see the intersection point clearly, and it gave me x equals 96.24 if I round, and y equals 1730.48 if I round. So p is the price, which is what they asked for. My price should be 96.24. Alright, to determine when dividing large degree polynomials by x plus 1 or x minus 1, it says start synthetic division using 0 placeholders for missing degrees, find the pattern, extend the pattern, determine the remainder. This is kind of just a pattern looking thing. I would never actually do this to figure out the remainder. I would use the remainder theorem to find the remainder. Put it quite simply, remember the remainder theorem says that if you want to know what the remainder is by some factor, do synthetic division by the 0. Or I'm sorry, you could just do direct substitution. I could find f of -1, which would be -1 to the 44th minus 15. If you raise a negative to an even power, that's going to turn it positive. And 1 to anything is 1. So I have this comes down to +1. Minus 15 would give me -14 should be the remainder. Okay? Let's see if that's true. If I put -1 in the hole, and I start with my 44th coefficient, 43rd, 42nd, 41, 40, 39, 38, I do not want to go all the way down to 1. So I'm just going to see if I can't figure out the pattern. Okay, 1's going to come out, multiplies by -1, brings back -1. So -1 comes out, goes to the store, multiplies, brings back +1. So +1 comes out, goes to the store, brings back -1. And you can see that it's alternating between +1 and -1. So what's it going to do all the way down here? Well, this is the 44th, this is the 43rd, 42nd, blah, 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 blah. This would be a sub naught. Okay, this would be the first term, and then this would be your constant. Yes? Well, let's look at what's happening. Your first term is an odd. Okay, 44th, 43rd, 42nd, 41. The next one would be the 40th. And if you look at all of the even terms, they're all +1s, where all of the odd numbered terms are -1s. Well, 1 would be the odd, so then the remainder would end up being the even one, which would be a +1. Yes. And so then my remainder would be -14. Okay? Alright, so you try this one. Come back when you're ready. Or just wait because my pen doesn't work. And I hope you got, waiting for the pen again. Alright, so if I do the pattern thing, I would put positive 1 in the hole. I have my x to the 34th, 33, 32, 31, dot, 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 down to negative 16. 1 comes out, is 1, is 1, is 1, is 1, is 1. This is going to keep going. Everything comes out of positive 1. So the final one's going to come out positive 1, which makes my remainder negative 15. Or you can find f of 1 and just do direct substitution. 1 to the 34th minus 16. 1 to anything is 1. Minus 16 would be negative 15. Alright, so how do you use synthetic division to divide two polynomials? I don't know why I started that one. We've already talked about that. You'd have to describe the synthetic division. And we are at homework, which means we are done. Happy homeworking, and I will see you next time.